Hi, this is Ms.Fitzmaurice. In this video, I'm going to go over with you problems 1 and 2 on page 15 of your Waves and Magnetism Unit 8 packet. So before I do this, I want to just quickly remind you, and you should have this kind of in the side, that the wave speed equation, v equals lambda f, where v is our speed, lambda is our wavelength, and f is our frequency. And I also want to remind you that frequency is 1 over the period. And I want to remind you that if we have an x graph, so a displacement distance graph, then the distance between the two high points is your is your wavelength. Whereas if you have an xt graph, the distance between your two high points is your period. Okay, that's the time it takes your wave to repeat. Alright, so let's look at number 1 first. In number 1, they want us to first find the amplitude. Remember that amplitude is the height from 0 to the top of a wave. So looking at this graph, no matter which of these two graphs you use, that height is 3. So we have 3 meters. The wavelength is the distance from high point to high point. So in this case, wavelength needs to be the distance graph. So from high point to high point, that's our wavelength. And so our wavelength in this case is equal to 8 meters. Frequency, we're going to need to use this equation frequency equals 1 over period to find the frequency. You can't just read it off the graph, but you can read period off of a distance time graph. And so this length in time is going to be our period, and it looks like about 15 seconds. Okay, so our period is 15 seconds. That means our frequency, f, is equal to 1 over 15 seconds. 1 over 15 seconds, which is 1 over 15 hertz. And then for wave speed, we're going to use v equals lambda f. In this case, our wavelength is 8 meters, and our frequency is 1 over 15, and so our wave speed is 8 over 15 meters per second. What I want you to do is I want you to try to repeat the same process with number 2. I want you to try to find the amplitude, wavelength, frequency, period, and wave speed, and then check back with this video for the answer. Alright, so now that you have tried this yourself, and if you hadn't, pause, try it yourself, even if you're not sure if you're going to be right. Let's go over the answers. So amplitude, remember, is kind of like the height of your wave. If we look at this graph, we see that height is about 1.5, and we can confirm that on the graph over here it's also 1.5. So we have 1.5 meters. The wavelength, remember I need to look for the displacement distance graph, so that's this graph, is the distance between two high points, so from 1 out to 5 gives us 4 meters. So we have the wavelength is 4 meters. Frequency, f equals 1 divided by period. And we need to use the time graph, distance time graph, to find the period. The period is the distance between two high points. So from 0 to 4, so t equals 4 seconds. Remember, this was wavelength. They're not always going to be the same, it's just a coincidence in this case. And so we have period t is 4 seconds, frequency is 1 over 4, which is 0.25 hertz. And then to get wave speed, we use v equals lambda f. We know that our lambda, our wavelength, is 4 meters. Our frequency is 0.25, and so we have 1 meter per second, because 4 times 0.25 is 1.